Okay, class, I need your attention and your listening skills today because we're going to cover a lot of material really fast. Okay, so the first thing I'm going to do is I'm going to ask you some questions, and I want you to raise your hand if you know the answer to the questions. It's okay if you don't know the answers to this question because it's kind of new material for this class, and that's what we're going to go through in this lesson. Okay, so now the questions are, 1, does anyone know how to describe isostasy? Would anyone be able to explain isostatic equilibrium? Would you be able to tell me what isostatic rebound is? Would you possibly be able to tell me what the major force is behind isostasy? Okay, it's okay if nobody knew the answers to that question. Okay, so now we're going to jump forward a little bit, and we're going to go into a story, and then we're going to backtrack, but I want you to pay attention for the vocabulary that was in the questions. Okay. Okay, once upon a time, about 2,200 years ago, there was this old Greek guy named Archimedes. Has anyone ever heard of Archimedes? Alright, so 2,200 years ago was also approximately 9,500 years after the beginning of the Holocene period, just for us geology nerds. Okay, so we have this old dude named Archimedes, and he is a genius. He's a mathematical genius, and he's hired by the king of Sicily to figure out a problem. The problem is that the king hired a jeweler to make a crown, and he gave him a bunch of gold and said, "Make me a crown out of this." And when he got the crown back, the king worried that the jeweler had stolen some of the gold and used some silver in place of the gold. So he told Archimedes to take the crown and figure out for sure whether or not it had been made of the gold, so he knew whether or not he'd been ripped off. But he had to do it in such a way that he didn't damage the crown. So Archimedes thought about it, and he thought about it, and he had absolutely no idea how to solve the problem, so he decided, I'm not going to mess with it right now. I'm going to go take a break. I'm going to get in a nice hot bathtub with my toys, and I'm just going to chill. So he's climbing into his bathtub. He's sinking down into his bathtub, and as he's sinking down into his bathtub, he notices how, as he's sinking, there's a certain amount of water that's being displaced, and it's the same amount of volume that is his body. So he stands up and he says, "Eureka! I figured it out!" And he jumps out of the bathtub and he runs around Sicily butt naked, just yelling "Eureka!" which means I found it in Greek. Anyway, he sort of fundamentally came up with the idea of buoyancy. Okay, we're going to get into that a little bit more after this brief activity. Alright, in front of you you have a clear plastic tub, and in that tub there is a special foam with some unique properties. What I want you to do with that is I want everyone at the table to take your hand, and I want you to push down on the foam, and then I want you to let up on the foam and watch what happens. And then you have some objects on your table. Each object has different densities. I want you to take each of those objects and put them in, and then pull them off and see how the foam responds. And then finally, I want you to take a few of these objects that you can pile on top of each other, put one in, watch what happens, and then stack them up, see what happens each time you put one on top of the other one, and then slowly take them off and watch what happens. I want you to write down a couple of your observations per your table, and then afterwards we're going to have like 6 to 7 minutes where we go around and we share our observations. Okay, so when we had an object on top of the foam, and that object pressed down into the foam, and then the foam stopped moving and the object stopped moving, that is how we understand isostatic equilibrium. When you pull the ball off, then the foam starts to rebound. That's called isostatic rebound. And the umbrella term for this is isostasy, which basically just describes the movement from and away from equilibrium, or a state of equilibrium. The basis for this idea came from Archimedes' bath. Now we're going to fast forward to the 1800s, and we had some scientists talking about how the lithosphere moves on top of the asthenosphere, or the crust moves on top of the upper part of the mantle. And what they were trying to figure out is basically how to describe the vertical movement of the plates. An example of this would be when you have two continents coming together, or two tectonic plates coming together, and they're colliding, and then they're pushing together, and they're just building a thicker piece of crust right there. Well, you're going to have an area that has a little bit more density than it used to have. So what it's going to do is it's going to weigh a little heavier in the asthenosphere, or the top part of the mantle, and until it stops moving, once the two continents have stopped colliding together, or once the two tectonic plates have stopped colliding together, and you have as much crustal thickness there as you're going to have, then it's eventually going to sink down as far as it's going to go, and both the asthenosphere and the crust will stop moving, and you're going to get isostatic equilibrium. And then, when weathering happens, and this can happen really slowly, really slowly or really fastly, but most often it's slow. You're going to have little pieces of rock that are going to weather away, and it's going to make this part start to rise back up. It's not going to be in equilibrium anymore. And then that part is going to rebound, and that's isostatic rebound. Okay, stop. Basically, it describes the vertical movement of the plates.